Hello everyone, welcome to the series of quick introductions to PLC programming. In this video, we'll explain the task configuration of PLC. First, understand a concept. PLC executes sequentially from top to bottom, and from left to right, executing instructions one by one. The time it takes to execute the entire program once is called the scan cycle. However, a complex project often contains various types of instructions. Some need to be executed in each cycle, such as emergency stop detection. Some can be executed once every 100 ms, such as temperature acquisition, and some need to be executed immediately when triggered by an external signal, such as interrupt. Tasks are to schedule and manage the execution of these different instructions. It stipulates which program block is to be executed at what time, what the execution frequency is, and which task takes precedence when multiple tasks need to be executed simultaneously. Task types include cyclic tasks, timed tasks, and interrupt tasks. These three types of tasks have different priorities, and task preemption is supported based on priorities. Interrupt tasks have the highest priority. Timed tasks have a higher priority than cyclic tasks. A low priority task can be interrupted by a high priority task. Each cyclic task has an independent task name and priority. The priority can be set from 1 to 255. When the previous cyclic task is completed, the next cyclic task is selected and started for execution according to the task priority, before being interrupted and suspended by a timed task. The cyclic task is executed in a loop according to the above-mentioned scheduling rules. Timed tasks are triggered and executed according to the set timing. Each timed task has an independent task name, timing, and priority. The timing can be set in the range of 1 ms to 31 days, and the priority can be set from 1 to 255. When the set timing is reached, the task is started for execution. If multiple timed tasks are ready at the same time, the task with the highest priority is selected and started for execution according to their priorities. Other timed tasks with lower priorities will wait until the high priority task is completed and then be executed in order of priority. Next, let's introduce the interrupt program. First, we need to understand the concept of interrupt tasks. For example, in our daily work, if an emergency occurs halfway, we have to stop what we're doing and deal with the emergency. The emergency being dealt with is called the interrupt program. After handling the problem, we come back to continue the original work. During the program operation, interrupt tasks are triggered through global variables or hardware variables. Next, I will demonstrate the operation process. There is already a program in the cyclic task here. Then, add a program for variable increment and add it to the timed task. Set the interval to 1000 milliseconds. After monitoring, we can observe that the variable increments by 1 every 1000 milliseconds. Then, add another program to demonstrate the interrupt task. For ease of observation, we can directly trigger the interrupt signal in the global variable table. It can be found that when an interrupt signal is triggered, the program in the interrupt task will be executed immediately. That's all for this video.